Are we going to learn some math today or what? Absolutely. And that brings me to my next point. Well, the main point, which is absolute value functions. We've been learning about functions all chapter, and we're going to specifically look at these things called absolute value functions. All right? And we know that absolute value is when you take the absolute value of a number, it's always the positive value. It's how far it is from 0. So we're going to look at functions that have absolute values in them. Like this example here, y equals the absolute value of x. So we have two goals. One is to graph absolute value functions, and two would be to translate absolute value graphs. So let's start us off. What is an absolute value function? Well, an absolute value function is a function whose graph makes a V shape. Here's a nice picture right there to the right. That would actually be the graph of y equals the absolute value of x. All right, it makes a nice V. What does translate mean? If you don't remember, it's a good refresher. Translate means to slide or shift a graph in some direction, vertically, horizontally, or both. So, how do you graph absolute value functions? Voila! I don't know if I've told you this saying before, but it goes like this. When in doubt, make a chart. T-chart, that is. So I don't know if you recall, when we first started looking at functions, any sort of function, and this will be like y equals, we'll just say the absolute value of x. We want to make a t-chart of values, so we can have some coordinates that we can just start plotting. And we want some positives and negatives, especially with absolute value functions. So we're going to do -2, -1, 0, 1, and 2. We get to choose those x values. And then plug it in. So if we plug in absolute value of -2, y is going to be 2, because the absolute value of -2 is 2. Absolute value of -1 is 1. 0 would be 0. Positive 1 would be 1. Positive 2 would be positive 2. All right, and well, let me actually. So when you were to graph that, if you were to graph it, I'll just make my own little t-chart here. All right, that was supposed to be black, but we'll go. Let's see. It will not be perfect, but you'll get the idea. -2, 2. -1, 1. 0, 0, 1, 1, and 2, 2. It makes a perfect V. And the point of the V is at the 0, 0, and the two other lines are just going up 1 and over 1 every time, whether it's positive or negative. So that's the basic, and this is maybe what you might want to memorize for the absolute value of x. Y equals the absolute value of x, because everything else kind of goes off of that. So we're going to start talking about different types of graphs off of that. So let's start off with this. Problem 1, it says below are the graphs of y equals absolute value of x and y equals absolute value of x minus 2. How are the graphs related? So look at them both. See if you can see any similarities and differences. I would start off by saying that they both have the same v. Same v. The only thing that's different is the vertex is different. And if you look at it, it's just 2 lower. So if you add or subtract outside of the absolute value sign, it's going to raise it up or send it down lower. Same v, it's just going to move the whole graph. That's called translating, because if you look at it, they used to be like this, looking like this. Same v is just translated 2 down lower. Everything is translated 2 down lower. All right, and that's one thing to note about graphing absolute value functions. So if you look at the thing, how is the graph at the right related to the graph of y equals absolute value of x? Well, again, it's the same v, but you may realize that it's raised up 4. So everything is up 4. It's still going to be the absolute value of x. It's just going to be plus 4. So that would be the function of that one, what the function rule is. Letter B, it says, what are the domain and range for each function in problem 1? Well, if you look at it, the range will never end. It'll go on forever. It'll continually go on forever. So the range is just all real numbers. But the domain, for the regular y equals, square root of x, it's always anything greater than or equal to 0. So say x is greater than or equal to 0. But for this one, it's x is greater than or equal to 4. Because it's 4 higher. So that's just one thing that would change the... Oh, sorry, that's the y. Y is greater than or equal to 4. So that would be the range. I had those two mixed up. Alright, let's move on to this next one. What is the graph of the square root of x plus 2? Well, again, you can make a t-chart if you want of x and y values, as long as you have positives and negatives, so you have a wide spectrum. Because we know every time you have absolute value, it should make a v of some sort. But, or you can use that rule and say it's going to go up. Sorry, up. I am writing y's instead of, y's instead of u's. I don't know why. Up 2. Okay, sorry. 2. So normally it would start at 0, 0, but it's going to be up at 0, 2. Everything else is going to be following suit, making this a V. So if you need to make that T-chart, go ahead. It's always a great way to check anyway. It's a good safety belt for graphing, because it always works, as long as you use enough numbers to spread out the graph. All right, problem 3, graphing a horizontal translation. So I kind of gave it away already. It says, what is the graph of y equals this absolute value of the whole quantity x plus 5? So I'm going to make a t-chart just to see how it works, because it seems weird if you look at it. It's y equals the absolute value of x plus 5. So I'm going to still pick some, like what if I pick the same numbers? It's not, let's do -2, let's do 0, let's do 2. It's a little bit different because it's inside of the absolute value now. So if you plug in -2 for x, -2 plus 5 is 3. Absolute value of that would be 3. So we have -2 and 3. That's this one right here. 0 would be absolute value of 5, which is 5. That's going to be way up here. And you'll notice if you do this, it's going to be 7. It's not even making a V yet. So we need to make it go, farther to the left to make a V. Let's try -4 and -6. Well, -4 plus 5 would be 1. So we'd have 1, -4 and 1. -6 and 2, that would make 1 as well. So now we just need to do -5. That'll give us our V. The trick, though, when it's added or subtracted inside the absolute value, is it's a horizontal translation. The only thing that's weird is it's x plus 5 on the inside, and it moves to the left. Like you would think it would be negative. So that is our unique rule here. So addition or subtraction inside of the absolute value bars causes a horizontal translation. So adding goes left, which is weird. Subtracting goes right. I'm going to actually add this. Well, we're going to leave that here. All right. I want to go back real quick, though, to this one right here, when we went to vertical. So I didn't add this in here. But adding or subtracting outside of the absolute value causes a vertical translation. Here, adding goes up, subtracting goes down. So that's the one thing that's different about these two. And it's something worth checking with a t-chart. And that's actually the last problem I'm going to do. We just want to work on graphing absolute value functions and moving them up and down or left and right. There are some other things you can do to absolute value functions, and that's what's going to get into my last question. What you think would happen if it was y equals negative the absolute value of x? All right. You could also have something like this, y equals 6 absolute value of x, or y equals the absolute value of 6x. So that's going to make it dilate either wider or narrower, and it's going to, like for this one, the negative, I'm going to give it away. I want you to think about it first, but it will actually make it go upside down. So there's lots of unique things you can do with absolute value functions. We just want to get into the habit of being able to graph them. So that goes back to our goals, graphing absolute value functions and translating them on the graph. All right. Hope you learned something about absolute value functions. Have a great rest of your day.